It is my job to lead a set of like-minded individuals to put out an Android build across all of our members' single board computers every month, at the same time every month, that work, are tested, and are easy to use. Our members' boards include the IMX53 from Freescale and now the IMX6 from Freescale, quad core. How's that for cool? We've got Panda. We've got, well, we're looking for BeagleBoard volunteers. And BeagleBone volunteers as well. We've got Samsung Origin. And we've got, my favorite, STE Snowball. A fantastic board, actually, especially for embedded systems. But this is not a sales pitch. I am only going through these boards because our experience supporting these boards has led me to this talk. Binary Blobs attack. And I think those who are actually in this industry will hopefully agree with me here. But that time spent on binary blob production, integration, and debugging has eclipsed any other activity in the product cycle. As they say, this is the problem. This is it. This sits at the root of almost every single problem in the device Linux ecosystem. As we saw before with our little skit, what you have is you set up this process where instead of being an interactive engineer like you are, you're now a batch engineer. Work, 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 work. Boom! Send it off into the universe, and the universe gets back to you, right? That's exactly how people used to program big batch machines. Work, 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 get my card deck, give it to the assistant runs through the machine, I get my answer back the next day. We are right back at that. Binary blobs also cause many, many problems, and we'll go through some of those problems here. All right, so let's rant for a little bit. Everybody needs to rant. Everybody needs to complain. Complain. That's all I hear from you guys. Anyway, binary blob scribbling is impossible to debug. What is scribbling on my memory? I don't know. It's in some goo of code that I got from some company that's in some place, and I don't even have a point of contact to talk to them. So what do? I sit there and I go through and I put print statements after print statements and bisect the code and go crazy. Kernel upgrades mean a recompile cycle with the SoC's third-party vendor. What if you don't have a third party? What if the third-party vendor is gone? What if the third-party vendor's guy or gal who did this is now working at the competitor's shop? Binary blobs are unethical. By not doing this. OS-independent code is always buggy, slow, and will only be used on the OS it's not meant for. So how do vendors, software vendors, try to handle the expansive universe of operating systems and devices and things like that? Well, they might create operating system independent code, and that operating system independent code is operating system independent, but the person who wrote it is probably thinking in their mind that, oh, this operating system is going to have this, like flat memory, and all the processes are in the same address space. All operating systems do that. If I want one module to communicate with another one, all I have to do is dereference a pointer, and I'm going to be cool, guys. I need debug symbols. How am I supposed to debug this thing? I don't have any debug symbols. My favorite? Documentation. Hello. I'm going to kick ARM out of the kernel. I can't track Linus's tip because I'll lose enablement. can't upgrade to 3.3 because my binary blob is locked to 3.0. I need a JTAG. Write once, run everywhere. Doesn't really work for Java. So how well is that going to work for a driver? So problems. The audio blob is locked to the 3.0 kernel. The graphics blob is locked to the 3.1 kernel. What do you want, graphics or audio? I know. I'll set up 2 units, and I'll make a network pipe between them, and then it'll be great. Hard FP and other toolchain improvements cannot be made, which means your binary blobs are locked in whatever way they were created, whatever way they were produced on whatever GCC or GCC compatible compiler, or even other compiler, and you're just communicating through some shared memory interface weirdness. Doesn't matter. You have no ability to improve these things globally using compiler optimizations, better compilers. The blob producers are always impossible to track down. I swear, it's like when you're debugging this stuff, you practice. It's like the Mafia, right? You got to know a guy. You know, everybody in this room knows a guy or a gal that worked at this company last year that knows the guy who actually produced the blob. And we engineers, we do deal with this all the time. We have this secret little network of the universe that we have that make things actually work, right? You know, USB keys that just happen to get left on desks, that just happen to have a certain thing on it. We have these processes in place. Things fall off the back of a truck all the time. And as I've said before, binary blob integration, because it has gotten so far out of control, has brought us back to batch development. I mean, it was okay back in olden times when, you know, okay, there's a Wi-Fi blob, and oh, okay, I can write a shim, and, you know, it's kind of self-contained. But then people got these ideas that they could do huge graphics stacks, and the graphics stacks just are instrumented and architected in a way that the use of binary blobs to actually distribute enablement just is breaking everything, and is really, like I've said before, is at the root of most of our problems, including the ARM problem. So almost everything in the ARM ecosystem has hardware acceleration that makes it work. An ARM SoCs without graphics acceleration are unusable. And if anybody would like to see what that looks like, come talk to me. I will show you a build. You run non-graphics accelerated 1080p Panda, it's really cool. It's really slow. The little mouse goes like this. Oh, I missed it. Go back. So this is not a nice to have. This is a must have. You must have these drivers to enable your platform. And as I've said before, these drivers are all locked to older kernels. They're all locked to older user spaces. I mean, it really is a disaster. And then you say, oh, well, Linus, I really need the shim in here because the shim, you know, it talks to this thing. And Linus, rightly so, says, are you freaking kidding me? I'm not taking that crap. So we're at the ARM problem. So what do we do? I mean, binary blobs are not going away anytime soon. In fact, they're multiplying. They're getting worse. So we can be open source and we can rail against the system and we can say, yeah, we work with these companies and then they eventually come around, but they don't. They don't come around. That's the whole problem. If they did come around, we would have, our trajectory would be looking less and less binary blobs. But what we see in ARM is that it's exploding. The number of cores in these SoCs is exploding, and every single device manufacturer is saying, oh, binary blob, that's exactly how I want to distribute my code. That's great. So the question is how can we ensure an open, sustainable software ecosystem with that? And let me tell you, when I say open, sustainable software ecosystem, what I mean is I have this phone, and I want to run what I want to run on it. And I want to run my own kernel, and I want to run my own user space, and I want to run not Android. I want to do whatever I want with Android. Android's fun, it's cool, it works. But what if I want to run Ubuntu on this phone? I should be able to do that. What if I want to run Red Hat on this phone? I can do that today with PCs, by and large. And whether UEFI comes in and destroys the universe, maybe this is the only platform I'll be able to run Linux on. It's a possible future. And anyway, I should be able to bring this thing to a conference and plug in a big screen and a keyboard and a mouse and do development on it. I should be able to do that. Not everybody wants to do that, but I don't care about anybody. I care about me. I want to hack on stuff. That is open, sustainable software ecosystem. So, what sits really at the core problem? So, to change the world, you have to start with where the world is. You can't start with where you want the world, because you're never going to get there. So you have to live in the world that you live in. So what is the world that we live in? A proprietary blob is really a blob. It doesn't even really care about what's running in user space and what's running in the kernel. And we've all seen this code. Anytime you've ever seen a device manufacturer give you a matching user space, kernel, and firmware blob that has to be used together, that's what they're doing. It's bleed over. It's super ugly. So, how does Windows deal with this? So I've heard. Well, Windows is a big blob itself. So blobs like to talk to blobs, and when blobs need to talk to blobs in a sustainable, closed software ecosystem, then the big blob tells the little blobs, you must absolutely write to this API. This is non-negotiable. This is the API you will use, and if you don't use it, well, tough. You're not going to be shipping Windows Mobile 7. Now, the market hopefully will decide that nobody wants those folks, but anyway, this is how Windows deals with it. And you especially see this in graphics stacks, right? So what does a typical proprietary stack on Linux look like? Well, there's a vendor proprietary user space proprietary blob. There's an open read write ioctl shim that's kind of part of that, may or may not be closed. There's a little open source right there, little teeny bit. Oh, just run this shim. You want 3D graphics? You totally do. And then you need this big proprietary blob in the middle, and then the Linux kernel sits underneath this. Now this is what it typically looks like. So SoC vendors are in the game to make money, and that's great actually. It's a free open market economy, and SoC manufacturers should be able to create whatever they want. And because it's a free and open economy, they think to themselves, okay, well, I don't really have the resources to implement this thing twice, right? Programming a video pipeline is insanely complex and insanely hard to get right. Ditto for graphics. Even Bluetooth and Wi-Fi is no picnic. So the enablement partners look at this and they say, okay, well, we just need to implement this once. So let's pick an operating system that, let's look at the features of an operating system and kind of create something that we kind of know. And well, the big operating system is where we're really going to make our cash. So we really need to make something that's kind of good. But oh, what is this Android stuff? Oh, Android's getting humongous. I have to do something about it. I mean, so that's where we kind of see that's kind of where we're at right now. And so what vendors will do is they essentially try to use they try to have their cake and eat it too, and the code that they develop is built in such a way that they can run it on Android and on Windows in the same sort of way. And as we see, like, you know, HTC or other phone manufacturers and SoC vendors, you know, this is the plan. This is the world as it exists now and how it will exist in the foreseeable future. So, what are some things we can actually do? We can actually examine what crosses the operating system barrier and see what we can do to decouple things. We can rethink memory and power policy and mechanism at the OS boundary. So things like memory allocation drivers, things like that. Actually, so a lot of this comes down to a lot of the complexity we see can actually be seen when you're trying to put together an open video analytics solution. So what does open video analytics look like? Okay, so you've got a video input device, you have a lot of buffers, you're doing analytics, so things are going to have to go through the CPU. There's probably going to be GPU involvement because you're probably video texture streaming to some GPU backend. You're not doing video analytics kind of locally, you're also involving the network because you're either asking the cloud for something or you're saying, you know, oh, what is the latest and greatest, like, or let's say I'm looking and I have my cool video, my cool T2 glasses, and I'm like, oh, look at that person. What is their Facebook posts? I mean, that's the world we're actually going to, and it's going to be so cool. But right now, there's really no good open solution for that entire chain. It would take a lot of work to actually get an open video analytic chain put together. And I don't know, given the current environment, whether it would actually be possible in any kind of useful time frame. And it certainly wouldn't be possible to take that and extend that video analytics in any open source sort of way. So if you had your cool Google specs with company X SoC in them, and you wanted to, for example, say, well, I want to hack on these a little bit, that would probably be extremely hard to do. But we'd figure it out, right? We'd figure it out. So we could create official binary box interfaces. So we could kind of take a page out of the Windows playbook and actually say, okay, well, binary blobs are going to exist with us, and we can say, we can either put our head in the sand and say, this isn't a problem, this is going to go away. Or we could say, nope, this is the interface. And then once we have an interface, then maybe we can have some sort of control over that interface, right? We can rev that interface. That interface gives people kind of a warm fuzzy. And device manufacturers would probably like having an interface, right? Because it would help their architecture teams kind of figure things out a little bit. Middle kernel, where like the video and the graphics drivers get enabled, where you're actually hooking into low-level multimedia or low-level allocation routines, which are bad, but that's what you do because you're trying to ship a product and you don't have a good higher-level API. And anyway, you're diddling page tables the whole time, so to get that last ounce of capability out of your chip. And then you have the higher level, right? You have the device drivers and things like that. And I think when you look at it, and why I say things like the memory, like creating actually a memory allocation type device, is that would actually pull a lot of what people do kind of in that middle layer out. And it would actually mean that, for example, like, let's say I want ion. Let's say I want CMA. Let's say, you know, I kind of want to encode, you know, like the boot mem, like contiguous memory. But I'm going to use it, I'm always going to use that in weird ways. I'm always going to, like, ARM has these really cool cache hierarchies and really cool ways of looking at memory and really, really low power. And so I would actually say that you can create all the CMA architecture things you want in the whole wide world, but people will always, always need to get in there and really do a device-specific tune of their contiguous memory space. And right now, what they're going to do is they're going to hack that middle layer of the kernel, and that's going to be icky. So we have a character device, we have block devices, we have network devices, and network devices are this weirdo thing, right? They don't act like character or block necessarily. So maybe we need memory devices, right? You know, if you can't beat them, kick them out. But ultimately, right? We need to. Right. Sorry, thinking of something else. So here's something, and this is something that my experience at Linaro has actually taught me, that corporations want to make money, right? This whole binary blob thing is ultimately killing them. It's ultimately slowing them down. So let's put it in their terms, right? And we kind of give this song and dance at Linaro all the time, right? If you work with the open source community and you upstream more of your stuff and you kind of try to, your trajectory is more open and your trajectory is more, you know, upstream focused, and you do your development in a way that kind of takes the open source community into account, then you're not going to chop yourself off at the legs, right? You know, you're going to be able to build a sustainable business, and you're going to be able to actually ship products sooner. And that's economic, right? That has nothing to do with any kind of rants or any kind of, you know, open source ideology that proprietary companies either have zero time for or a little bit of time for and give lip service to. But then there are the ones that are actually doing these things, and you see that these companies are, you know, generally regarded as more successful, and their products are actually more stable, and they're better. So there is a little bit of that going on. But what you could say to some of these companies is say, look, I want you to create, I don't want your 60 FPS graphics driver. Keep that, sell that, do whatever you want. I just want some 3D graphics enablement so that I can replace the 3D graphics enablement that's on my phone with something that will generally work. Maybe I'm not going to play Battlefield 3, but I could at least have some fancy graphics and spinny things and some basic graphics support. So what you say is, well, why don't you actually create and sponsor and fund open source teams that can actually take some of the capabilities and create open source versions of these binary blobs. And the payback is that these engineers that are actually going to work on these things are going to be the exact same engineers that you're going to want to pull from and talk to, because they're going to be the enthusiasts. They're really going to push the envelope of that non-proprietary solution. And after doing this for a few cycles, what will probably happen is that the non-proprietary guys are going to be so awesome and what they're going to produce is going to be so cool, and it's already going to be out in the open, that becomes the default, right? So there you go. You get in, you get it out the door, and then you keep it out the door, and you execute. Because what do companies respond to better than anything else? Execution. Talk is cheap. But if you can actually do something, create a way forward that makes economic sense, then you can have your cake and you can eat it too. And of course, We can always reverse engineer stuff. This becomes very hard when you're talking about firmware that lives on some core out in the ether of the chip, but it's all possible. And people have been known to do this. So you have the new R-Molly open source solution that is getting developed, and that's good, you know. But the thing is that we shouldn't have to go down this route, right? It shouldn't have to be that conflict. We should actually say, look, you guys are getting a lot of value out of Linux, and you guys are shipping devices in a variety of method that you would have never been able to do with this proprietary ecosystem that you guys used to have. And we know you want to be successful, and we know you don't want to get sued, because the elephant in the room is that really the device manufacturers don't release these because of the legal implications of doing so. And so maybe things like creating an open lawyering organization that can handle that sort of thing, right? Outside the box thinking. It's not all just a technical issue. In fact, most of this, when, you know, we're engineers, so we say, well, to hell with you, I can do whatever I want, I'll just be smarter than you. But if you can get, you know, kind of the outer, you know, other people involved in the open source world, then they can help you. And lawyers are cool. There are lawyers who care about open source. So, feel free to send me questions, rants, anything you'd like to my email address. I'm always PfefferZ on #Linaro-Android on irc.freenode.net. And you can always hit me on G+, at Zack Pfeffer, not the soccer player. Because there's a cool soccer player named Zack Pfeffer. What? Why don't you like soccer? No, I love soccer. I'm not that guy.